Good afternoon. Good afternoon. Okay. So in the last class, I said the formula of the fringe width. And what was the formula of the fringe width? Beta is equal to capital D lambda by small d. I think this everybody know that. And what is the fringe width? Fringe width is the distance between consecutive maxima or consecutive minima. Okay. Either consecutive minima or consecutive maxima, then the fringe width is what? Capital D lambda by small d. And that is a YDSE. This is the property that you have to remember. In YDSE, we are taking the fringe width is constant throughout. Maybe diffraction, if you remember, in the diffraction central maxima, we got the width is the double of the secondary maxima. Central maxima width was double, but in the YDSE, all maxima equally bright, all minima equally dark, and the fringe width is constant throughout the screen. Okay, and that is equal to what? Capital D lambda by small d. Okay. Second thing, angular fringe width. Angular fringe width is what? Like this is the maxima, central maxima, and suppose here is the first maxima. Okay, so what is the fringe width? Fringe width is the distance between either consecutive maxima or consecutive minima. So this is what? Beta. This is what? Beta. What is the angle it is making here? That is called the angular, means angle subtended by the fringe width at the bisector of the slit. That we can take as a angular fringe width. Okay, so what is the angular fringe width? So we know that angle is equal to arc upon radius. Okay, here fringe width is a very small quantity, so this distance is very small. So for the small angle, we can take the straight length as the arc length. So this beta we can take as a arc, because this angle will be very small. Or we have learned for a small angle, sine theta can be written as tan theta, can be written as theta. So directly I can write alpha. Alpha is the opposite side upon adjacent side. So what I will get? Beta by capital D. Beta formula is what? Capital D lambda by small d. So then it will get lambda by small d. So this formula you have to remember for the angular fringe width. Okay, and the fringe width is what? Capital D lambda by small d. Up to this everybody got? Okay, next thing, suppose we are performing like YDSE experiment, we are performing in any liquid where the refractive index is mu. We are performing the YDSE in the liquid where the refractive index is mu. Then without disturbing the setup we are not disturbing. Okay, setup not disturbing means capital D, small d, these are constant. But when we are performing in the liquid of refractive index mu, so we know that wavelength of the light will become lambda by mu. Okay, so if YDSE we are performing in the liquid, liquid of refractive index mu, then we can say rest thing will be same. So beta liquid, beta in the liquid or beta dash, what I can say? Beta by mu. Whatever is in the air or beta medium, I can say beta air by mu. And alpha medium, what you will get? Alpha air by mu. Because in both formula we are getting the lambda in the numerator. Lambda in the numerator. So lambda I will replace by lambda by mu. Completed? Okay. Next thing I said, what is the definition of the central maxima? What is the meaning of the central maxima? Okay. So central maxima is not always the bisector. Central maxima is not always bisector. What is a central maxima? It is a point where the path difference is zero. Central maxima definition is what? It is a point where the path difference is zero. So central maxima is path difference is equal to 0. Where the path difference is 0, that will be the position of the central maxima. It may or may not be the bisector, okay, bisector of the slit. Okay, why? Because suppose before the slit, some phase difference is there, some path difference is there. So after the slit, path difference will not 0 at the bisector. Suppose I am taking the example, 2-3 example in the NCERT also they have taken. These are the slit, O is the bisector, okay. Suppose I am taking the primary source S at the bisector. This is the primary source, okay, what the Young has done. Now, primary source is put symmetric with respect to S1 and S2. So before the slit, you can see SS1 and SS2 are equal. Before the slit, SS1 and S2 are equal. It means before the slit, no path difference is there, okay. So after the slit, where the path difference will be 0 at O, because S1O and S2O will be also equal. Now overall path we have to see S1O is equal to S2O. Then it means we will get the central maxima at the bisector. We will get central maxima at bisector. Okay. So this will be the central maxima. But suppose primary source I am putting like this. Where the central maxima we will get? Where you will get the central maxima? Above O, below, at O. No answer. Above O, below O, above O, below O, below. Now listen, what I said, central maxima is the point where the path difference is 0. Okay. If you are taking the primary source above, like this, then now you can see before the slit SS1 and SS2. Okay. Whose path is lesser? Before the slit, whose path is less? Wave has to travel lesser distance to reach to the S1. SS1, you can see in the figure, SS1 is less than SS2. So before the slit, whose path is lesser? S1. Okay. Central maxima definition means where the path difference is 0. Now after the slit, whose path has to be more, then they will be equal. Because path difference 0 means path has to be equal. Before the slit, S1 is less. So after the slit, who has to be less? After the slit, whose path has to be less? Because overall path difference we got 0, means overall path length has to be equal. Now we will get the central maxima below O. That will be the what? Central maxima. Why? Because before the slit, S2 path more. Before the slit, S2 path more. So after the slit, S2 path has to be less. Who is playing with the screen? Now we can say what? SS1O dash, SS1O dash is equal to SS2O dash. Everybody got? Then central maxima will shift down. Everybody got? Okay. Now in this case, suppose I am taking the S is down. If S is down, then central maxima will shift up, because before the slit, S2 path less, then after the slit, S1 path will be less. Then only we will get the central maxima. Completed? Okay. This case, suppose I'm not taking the primary source like this. I'm taking primary source at far distance. Okay, and this type of light ray fall on the slits, where you will get the central maxima at the bisector, above the bisector, below the bisector. So where we will get the central maxima, at O, above O, or below O? Now here, if you see the parallel beam of light, it will fall S1, and then for S2 path length is more, because S2 it is traveling extra. Okay, so suppose it incident at an angle theta here, this angle are theta, then where the central maxima will shift. Now you can see before the slit whose path is more, S2 path is more. So after the slit whose path has to be less, S2 will be less. Then only the path length will be equal or path difference will be 0. So in that case, central maxima will shift down. Okay, central maxima will shift down. If suppose they are asking at what angle, so directly you have to remember it will shift at an angle theta below. This angle will also be theta. This will be the O dash. O dash is what here? Central maxima. Everybody got? So what angle the incident light ray parallel beam of light fall on the plane of the screen? At same angle central maxima will shift. Okay, if it is a falling, then it will shift below. If this is a falling, then it will shift above. Okay, everybody got? Okay, next point. Suppose they are saying in the central maxima in the YDSE, at any point when we are using the wavelength lambda 1, then at any point suppose I am getting the maxima, n1th maxima. Okay, and when we are using the lambda 2, then at the same point we are getting this maxima or this minima. When they are using the word same point, same distance from the bisector or same distance from the central maxima, same point means what? I said same point means y same. If y same, then path difference we know in the terms of y. What? Delta x is equal to dy by capital D. Now point same means P. Suppose I am taking point P. So y same. Setup I am not disturbing. It means small d and capital D same. It means what? Path difference will be same. So when they are using the word same point, it means path difference we have to take same. Okay. If they are saying maxima, for the maxima we know the path difference is what? N lambda. For minima it is 2n minus 1 lambda by 2. So if I am using lambda 1 and lambda 2, and they are saying when I am using lambda 1, at that point I am getting n1th maxima, and when I am using lambda 2, at the same point I am getting n2th maxima, then what is the condition I will use? Path difference same, then n1 lambda 1 is equal to n2 lambda 2. If I am saying when I am using lambda 1, at that point I am getting the n1th maxima, and when I am using lambda 2, at the same point I am getting n2th minima. So one maxima, one minima. Then delta x, what I will say? Delta x same. Now for maxima I will say n1 lambda 1. For minima I will say 2 n2 minus 1 into lambda 2 by 2. Minima condition, path difference should be 2n minus 1 lambda by 2. Maxima condition, n lambda. So directly don't mug up that n1 lambda 1 is equal to n2 lambda 2 if they given the two wavelength one number. So other number I will find by using the n1 lambda 1 is equal to n2 lambda 2. According to the given condition, if they said the same point means path difference same. Now, if they are saying the maxima, so we will equate the path difference for maxima. It means n1 lambda 1 is equal to n2 lambda 2. If they said minima, we will equate the minima path difference. That is a 2 n1 minus 1 lambda 1 by 2 is equal to 2 n2 minus 1 lambda 2 by 2. If they said 1 maxima, 1 minima, we will equate the maxima and minima. It means according to the problem we will do. Okay. Then I can say what? For lambda 1 and lambda 2, at same point, then I can say delta x1 is equal to delta x2. So we will directly equate the path difference. They given maxima, we will equate for maxima. They given minima, we will equate for minima. Everybody got? Okay. Next point is what? Suppose we are using already in the NEET 2023-24 they asked this question, 24 they asked white light. If we are using the white light in YDSE, white light means how many colors? 7 colors are there. Okay. So one thing I said, for the stable interference pattern, we have to take the monochromatic wavelength. Monochromatic wavelength, why? Because when I'm taking single wavelength, then I can easily recognize where is the maxima, where is the minima. All these we can recognize easily. But when we are using more than one wavelength, then whose max, maybe I'm getting lambda 1 maxima, but it will be the lambda 2 minima. So what will happen? Throughout the screen, we cannot recognize where minima, where maxima. So to see the stable interference pattern, clear interference pattern, we are using the monochromatic light. Okay. But suppose we are using the white light in the YDSE. White light means 7 color. Then what we will get on the screen? Okay. What pattern we will get on the screen? Okay. So there we cannot identify minima, maxima, but like here darkness, here brightness. Why? Because darkness means all are missing, but it is not necessary 7 color are there. Maybe red is missing, green will be there. So we cannot recognize minima, maxima, but what pattern we will get on the screen, how we can decide. When I'm using white light, now at the bisector S1O and S2O are equal. S1O and S2O are equal. Okay. They are equal, then it means path difference is 0 at O. So path difference 0 at O. So path difference 0, it means it doesn't depend upon the lambda, because for maxima n lambda, for minima 2n minus 1 lambda by 2. But path difference 0 means 0. Lambda 1 if I'm using for that 0, lambda 2 I'm using for that 0. It means bisector is the maxima for all color, all wavelength. Bisector is the maxima for all wavelength. Now O is the bisector, or O is the maxima of all color. It means all color will be have high intensity at O. All color will have the high intensity at O or more intensity at O. Now all the 7 color they will meet at O. Then what will be the O? O will be the white spot. O will be the white. So in that case we can say central maxima is white. Why? Bisector is the maxima for all color. Maxima of all color means all color will have the more intensity. All color will have more intensity. So all color will meet there. All color will meet there. Then we will get what? White spot. Everybody got? Okay. Up to this okay? So central maxima is white. After that, what will happen on the screen? So then we will get the minima. After the central maxima, we will get first minima. First minima means path difference should be first minima. Path difference is lambda by 2. Path difference is lambda by 2. Lambda is minimum for violet and maximum for red. So after the central white, what we will get? First minima. This side also, this side also. Now first minima. First minima means it is that color is missing. That color is missing. Minima means its intensity is 0. So whose lambda? First minima means path difference should be lambda by 2. Lambda is minimum for violet. Lambda is minimum for violet. So closer to central white, whose minima we will obtain first? Whose minima we will obtain closer? Violet minima. So closer to the central white, whose minima is closer? Violet minima. Violet minima is closer. Are everybody getting or not? Closer to the central white, we will get the minima of violet. Minima of the violet means violet color is missing. Violet color is missing means violet intensity is 0. Violet, blue, their wavelength are nearly equal, so they will be missing. So the dominant color will be what? Red, orange. So fringe will appear reddish. Okay, fringe will appear reddish. So if they are asking the question, closer to the central white, whose minima is obtained first? Which color minima obtained first? Then answer is violet. Answer is violet. But if they are asking which color fringe we will observe closer, what is the fringe color closer to the central white? So fringe color we will say reddish. Fringe color we will say reddish because violet, blue all are missing. So the intensity of the red, orange will be more. So it will appear as reddish. Everybody got? So if I am asking closer to the central white, whose minima is closer to the central white, whose minima is obtained? Violet minima. But what is the color of the fringe? It will be reddish. Okay. Now as you are going far from the central white, first minima of the violet you cross, at some point you will get the first minima of the red. First minima of the red. Why? Red wavelength is maximum. So whose minima will be far from the central white? Red. Now red is missing. Red intensity is 0. Red, orange intensity 0. Then whose intensity will be more dominant? Blue and violet. Then it will appear as a bluish. Then the fringe will appear bluish. Again I am repeating, central white, whose minima first? Violet minima first. So what is the fringe color? Reddish. Far from that, whose minima is obtained? Red minima is obtained. Red minima, so what is the fringe color? Bluish. Everybody got or not? Completed? Okay. Up to this okay? Now, so white light and all, everything clear. In the beginning I said screen has to be the far distance, screen distance should be large in comparison to the slit distance to see the clear interference pattern. Otherwise, maxima and the fringes will start overlapping. Okay. Now we will come to the problem. So suppose I am saying if I am using the two wavelength, lambda is equal to 6000 angstrom and lambda 2 is equal to 8000 angstrom. We are using one by one. Two wavelength we are using in the YDSE. One by one, first I am using 6000 angstroms, then I am using 8000 angstrom. Distance between the slits I have given D is equal to 1 millimeter and the capital D I gave suppose 1 meter. Okay. I am asking find the minimum distance of the point, from the central maxima. If they not mention anything, central maxima we will consider at bisector. Otherwise they have to mention how we have put the primary source and or how the light is falling on the slits. If they not mention, then we have to take what? Initially before the slit path difference is 0. Okay. Then after the slit where the path difference will be 0 at bisector. So if I am saying central maximum is by default we have to take the bisector. So what I am saying here, if I am using the two wavelengths 6000 angstrom and 8000 angstrom and D and capital D I gave, I am asking minimum distance of the point from the central maxima where these two, their maxima will coincide. Means when I am using lambda 1, I am getting maxima. I am using lambda 2, I am getting maxima. What is the minimum distance of from the central maxima where their maxima will coincide? So find minimum distance of the point on the screen at which lambda 1, lambda 2 maxima coincide, or they will say bright fringe coincide. Okay, minimum distance. Okay, capital D 1 meter, capital D 1 meter. Okay, now listen. Maxima coincide and same minimum distance of the point, same point I am saying, then it means what? Y same, then path difference same. Okay, so Y same means path difference same. Path difference same, then what I can say? Delta x1 is equal to delta x2. Now I am saying the maxima for both, then I can say what? N1 lambda 1 is equal to N2 lambda 2. Then from this N1 by N2, what I will get? Lambda 2 by lambda 1. That is equal to what? 8 by 6. Now listen. This type of problem, first we will find the simplest ratio. We will find the simplest ratio. Simplest ratio means number has to be relatively prime. After that, they should not, like, no any common number has to be there. So we will simplify up to the all common number we will cancel. Okay, so like 8 by 6 means here 2 factor is common. Then after cancelling we got what? 4 by 3. Now 4 by 3, no any common number is there, no any common integer is there. Okay, now after getting up to the simplest ratio, then now directly I can say minimum number means N1 value is what? 4, N2 value is what? 3. N1 value is equal to 4, N2 value is equal to 3. I cannot say for the 8 and 6 also possible, but that will be the other. Suppose first I got 4th maxima of lambda 1, 3rd maxima of lambda 2. Then I will say 8 maxima of lambda 1, 6th maxima of lambda 2. Then I will say 12th maxima of lambda 1, 9th maxima of lambda 2. Like this way, different point, their maxima will coincide. But what is the minimum number? Minimum number we will decide when we will have the what? Simplest ratio. Now in the simplest ratio, I can say N1 is equal to 4, N2 is equal to 3. Everybody got or not? So minimum value, what I will say? N1 is equal to 4 and N2 is equal to 3. Okay. Now I am asking the distance. It means I am asking the Y. Then what I can say? dy by capital D. Same point means Y will be same. dy by capital D. Now you have the choice. You can write N1 lambda 1 or you can write N2 lambda 2. If you are writing N1, then N1 value will take 4. Lambda 1 what I gave? 6 into 10 to the power minus 7. Otherwise N2 if you are using, so 3 into, then you will use the 8 into 10 to the power minus 7. Small d I gave 1 millimeter means 1 into 10 to the power minus 3. Y I am asking, distance I am asking, so this is the Y minimum. Upon capital D what I gave? 1 meter. After solving, you will get the minimum distance. Everybody got or not? Okay. Suppose here I gave in the YDSC we are using some wavelength and 2 slits I gave S1 and S2. Okay. At any point P in the front of the slit. It is a front of the slit. Okay. Front of the slit. If I am getting the first minima, if I am getting the minima, suppose in the front of the slit, one of the slit, we are getting minima. Then what are the possible wavelength we can use? Again, I am repeating in YDSC. In the front of the slit, we are getting the minima. Then this value also I gave, capital D is equal to 10 small d. Okay, if required, then D we can take 1 millimeter. Then I am asking what are the possible wavelength we can use in this experiment. Okay, so front of the slit, one thing you have to remember, front of the slit means which quantity we know. we know the y. So when they are saying front of the one of the slit, front of one of the slit means from the bisector, what is the distance? This is the bisector, so this distance is what? Y, and y what you will take? D by 2. Y what you will take? D by 2. So when they given the front of the slit, it means we know the y. What is the y? D by 2. Then path difference, what I can say? At P, path difference delta x is equal to, we know the formula dy by capital D. You will remember like this only, dy by capital D. Otherwise dy by D, you will get confused. Which y? Which D? Capital D or small d? So we have to remember what? Delta x is the dy by capital D. Okay. Now in the front of the slit, what is the y? Y will be d by 2. Then I will get what? D square by 2 capital D. This is the path difference I got in the front of the slit. Okay. What is the capital D I gave? 10 small d. So d square upon 2 into 10 small d. 1d cancel out. What you got? D by 20. This is the d by 20. Around 140, 130 I will complete because I know that you are hungry. Some questions are there in the notes. Now you can try all those questions. If any after that any doubt is there, then you can ask in the study hour when you will come back. Okay. So main problem is where the students are facing the problem, and those problems are important. That only I am discussing. Simple question that I'm not going. What is a capital D effect? What is a small d effect? Capital D, small d values they given. What is a fringe width? All this you can do. Okay. Now what is our delta x? I got d by 20. Okay. Now I am saying I am getting the minima. I am getting the minima in the front of the slit. So for the minima we know delta x is equal to what? 2n minus 1 lambda by 2. 2n minus 1 lambda by 2. If in the value I am saying, so either lambda by 2 or 3 lambda by 2 or 5 lambda by 2 ... like this. Okay. This is the condition for minima. So one thing in the whole YDSE chapter, the role of the mainly the whole chapter is the role of the path difference. Okay. One path difference we are finding from geometry, and one path difference we are writing from the condition of maxima and minima. So generally in the whole chapter this is happening. If I am saying a distance of the point is y, so I know the path difference is dy by capital D. Now it is a maxima, then I can write n lambda. If it is a minima, I can write 2n minus 1 lambda by 2. From these two things we have calculated everything, fringe width, angular fringe width. Later when we will introduce the thin slab in the front of one of the slit, then also the role of the path difference is only there. Due to that, central maxima will get shift. Okay. So this chapter there is a important role of the path difference. So here minima means path difference is this. Okay. Now delta x, what I got? D by 20. D by 20. That is equal to either lambda by 2 or 3 lambda by 2 or 5 lambda by 2, like this. Everybody got or not? So suppose in the question I ask, what is the maximum wavelength we can take? What is the maximum wavelength we can take? Suppose in this question I am saying, what is the maximum possible wavelength we can get? Who will say what you will do? In this question, if I am asking, what is the maximum wavelength we can take? What is the maximum possible wavelength we can take? Anybody? So now here, if you take this condition, then lambda you will get what? D by 10. Okay. If you are taking this, then what is the lambda you will get? So lambda max, if I am asking, so first condition, lambda by 2 is equal to D by 20. This cancel out, what you got? D by 10. If you are taking second condition, second minima, so 3 lambda by 2 is equal to D by 20. Then what you got? Lambda is equal to D by 30. Like this, different lambda you will get. So they will not ask minimum lambda, they will ask maximum lambda. Maximum lambda you will get when you are equating with lambda by 2. So this is the lambda max. So what is the lambda max you will get? D by 10. D value already given. From that you can calculate maximum wavelength we can take in this. Okay. Everybody got? So suppose I am saying maximum intensity on the screen is I naught. Okay. Fringe width I have given. This question maybe you have done also. Fringe width is equal to beta. Then intensity at a distance y on the screen. In the YDSC, if they not mention, always we are taking the intensity of both sources are equal. Okay. If I'm saying what fringe width is the beta and I'm asking, then what is the intensity at a distance y on the screen from the central maxima? If not mentioned, then it means from the central maxima we have to measure. Then what is the intensity you will get? So YDSC, what I said, intensity we are taking equal till they are not mentioning. So equal intensity, then resultant intensity formula we have learned. I naught cos square delta phi by 2. Are remember or not? This intensity formula, remember or not? Then delta phi. What is the delta phi? Delta phi is the 2 pi by lambda into delta x. Okay. Now delta x, what how we can find dy by capital D. Okay. Everybody getting or not? So delta x, what I can write? Dy by capital D, but I have not given small d and capital D. I have given beta. So beta I can get what? How we can get the beta? By multiplying with lambda, suppose. So capital D lambda by small d. Okay. Everybody getting or not? So delta, otherwise delta is directly you can use dy by capital D. This I am directly putting here. So 2 pi by lambda into dy by capital D. Now capital D lambda by small d. That will be what? Beta. So this I can say what? 2 pi y by beta. Okay. After getting this delta phi I got. Are everybody getting or not? So then I resultant is equal to what? I naught cos square phi by 2. Phi by 2 means it will be what? Pi y by beta. So this is the intensity at a distance y on the screen. Completed? Okay. Next, very simple problem. You will say the answer. So this is the slits. I am using what? White light. Find distance of white spot from O. Find the distance of white spot from O. O is not a bisector. In the figure you can see. I am asking what is the distance of white spot from the O. Distance of white spot from the O. So listen, just now I discussed what, where we will get the white spot. We will get the white spot in the case of common sense question. Yes, white spot we will get at bisector. So suppose O dash is the bisector. This is the white spot. Okay, bisector of the slit means the distance from the slit is what? This distance is what? D by 2. Okay. Now white spot from this is the D by 2. What is the distance of the O from the S1? D by 3. I need O dash. This distance I want. Distance of white spot from O, it means I'm asking this. So what is this? From here it is the D by 3 and green is the D by 2. Now what is the distance between O dash? O dash is equal to what? D by 3 minus D by 2. That is equal to what? 6 you can take common, then 3 D by 2 minus D by 3. Oh, wait. This is the D by 3 I gave, na? So here D by 3 I have given by mistake, I have given more. So it is better that this distance I am giving 2D by 3. Okay, sorry. So this is the 2D by 3. I am asking the distance of the white spot from the O, because D by 3 will be lesser than D by 2. Na? Then I am asking the distance of white spot. So this is the white spot O, and this is the what? Distance I gave 2D by 3. Now O dash is the white spot. Somebody calculated the answer also. That is according to the figure, that was the incorrect. Otherwise, that question also we can solve. Here, this distance I gave 2D by 3. White spot we will get at bisector. What is the distance of bisector? D by 2. This distance is what? D by 2. Now, what is the distance you will get? O dash is equal to what? 2D by 3 minus D by 2. Now, suppose you took the 6 LCM. Then here you got the 4D. Minus here you will get the 3D, that is equal to D by 6. Okay. Completed. Up to this everybody got. Now this one question came in the NEET also. If in the YDSE perform in air, then at any point fifth maxima is obtained. Fifth maxima is obtained. If it perform in liquid, refractive index I am taking what? Mu. Then at same point or same distance, they will say same point, eighth minima is obtained. Then find mu. So what is this question here? If YDSE is performed in the air, then at any point we have got fifth maxima. But if it is performed in the liquid of refractive index mu, then at the same point we got the eighth minima. Then we have to find the mu. Why it is happening? Because when we will perform in a liquid, so when refractive index increase, then whole pattern become narrower. Why narrower? Because lambda will decrease, fringe width directly proportional to lambda if I'm not disturbing the setup. Now in the liquid, lambda will become lambda by mu. Lambda decrease, fringe width decrease. Fringe width decrease, so in the same distance, what will happen? More number of fringes will come. That's why we are getting the eighth minima in the medium. At the same point, we are getting the eighth minima. Are everybody getting or not? So suppose I am saying in the place of the air or vacuum, we are performing the YDSE in the liquid whose refractive index is the mu, then whole pattern become narrower or fringe width will decrease. Okay. Same point means what I said. If I am saying the same point means Y is same. Y same means path difference same. So I will say what? Delta x1 in the air, delta x in the air, that will be equal to delta x in the liquid. Okay. In the air, I gave maxima. Which maxima? Fifth maxima. So I will write what? 5 lambda. In liquid, I gave minima. For the minima, we are writing path difference is what? 2n minus 1 means 2 into 8 minus 1 lambda by 2. In liquid, what is the lambda I will take? Lambda by mu into 2. This everybody got or not? Now lambda and lambda get cancel out. Then what we got? 5 is equal to 8 to the 16 minus 1, 17. 17 by 2 mu. So what is the mu here? Somebody is saying 1.5. What you are doing? How 1.5? Okay, 8 to the 16 minus 1. Sorry. 8, 16 minus 1, 15. Then you will get the mu is equal to what? Mu is equal to 1.5. Okay, mu is equal to 1.5. Completed? Now one thing, theoretically you have to remember what is the shape of the interference fringes on the screen in the YDSC. If they not mention what we are using the pinholes. We are using pinholes. So what is the shape of the fringes we will take? We will take shape of the fringes is hyperbolic. If they not mention, only they are asking what is the shape of the interference fringes in the YDSC, then we will go to the hyperbolic. Shape of the interference fringes is hyperbolic. Everybody got or not? Last topic that you have learned when we are introducing the slab in the front of the slit. Okay, suppose last topic. Suppose slits I have taken S1 and S2, and in the front of the S1 I am putting the one slab of thickness T and refractive index mu. In that case, what they will ask, at what distance central maxima will get shift? The central maxima will get shift by the 10 fringes, 5 fringes, or it is shifting at maxima minima, they will give. Why the central maxima will shift first? So suppose here we are putting the slab in the front of the one of the slit. Then what will happen? This slab will introduce the extra path length, or it will introduce the path difference. Why? In ray optics we have learned, suppose you have any medium, you have any slab of thickness T and refractive index is mu. If the light is traveling a distance T in the medium, so what is the corresponding air distance? That is called the optical path, and optical path will be equal to mu T. Okay, so this in the optics maybe sir said, when light is traveling a distance T in the refractive index mu, so corresponding air distance is called the optical path. And what is the optical path? Mu T. Okay, so when the wave is crossing this, wave is traveling through this slab, rest distance is in the air for the S1 also, for the S2 also. Here to here it is traveling in air, here to here it is traveling in the air. S2 overall whole distance it is traveling in air. So what we will do? First we will write both distance in air. So only who will create the difference? This slab. If the slab it is traveling T, then corresponding air distance is the optical path. What is the optical path? Mu T. So here air distance is what? Mu T. But here what is the air distance corresponding to this slab? T only. Why? Here only air is there. I can imagine air slab of thickness T. So S2 is traveling T distance in air. So S1 is traveling, corresponding to that S1 is traveling how much distance? Mu T. Okay, so who is traveling extra? Upper slit is traveling extra. How much? Then I can say delta X is equal to what? Mu T minus T. That is equal to T into mu minus 1. Up to this everybody got or not? Okay, so who introduced the extra path? slab has introduced the extra path. How much extra path we got? T into mu minus 1. Up to this, okay? Okay. So then now, which wave is traveling extra path length? S1 wave is traveling extra. S1 is traveling extra, so according to the definition of central maxima, their path difference has to be 0. But at O, path difference is not 0. Why? S1 wave is traveling extra. Then where the central maxima will shift? Central maxima will shift above. Suppose it is a O dash. That is the central maxima. So one thing we have to remember, central maxima will shift towards the slit where we have introduced the slab. Central maxima will shift towards the slit where we have introduced the slab. We introduce the slab in the front of upper slit, central maxima will shift above. We have put the slab in the front of lower slit, central maxima will shift below. Okay. So here central maxima will shift above. Why? Because S1 is in a S1, slab is introducing extra path. So means central maxima path difference has to be 0. So if I will shift this above, so this overall path, this path will become equal. This become equal, so central maxima we will get. Okay. In that case, central maxima will shift above. If I am saying how much distance the central maxima will get shift, it means I am asking y. Then this distance I will equate with dy by capital D. If they are asking what distance the central maxima got shift, so distance they are asking, it means y they are asking. Then I can equate with dy by capital D. How many fringes central maxima got shift? How many fringes central maxima got shift? If the number of fringes I am asking, so central maxima, it is shifting to the other maxima, then I will equate with n lambda. So again I am repeating. If they are saying how much distance central maxima got shift, so t into mu minus 1, I will equate with dy by, I said what? It is the role of the path difference only. So how much path difference introduced by the slab? T into mu minus 1. Then how much central maxima got shift? Then I will equate with dy by capital D. How many fringes central maxima got shift? Earlier here, central maxima, now it shifted to the fourth maxima. Then I will say that is equal to what? 4 lambda. So number of the fringes central maxima got shift. So t into mu minus 1, we will equate with L lambda. Suppose they are saying it shifted to the minima, first minima, second minima, third minima. Then we will write here lambda by 2, 3 lambda by 2, 5 lambda by 2. From that they can ask any. Okay. So in that case, if they are introducing the slab, first thing what we have to remember, fringe width will not change. Maybe somebody can think, sir, light is traveling in the medium of refractive index mu. So light wavelength should be lambda by mu. No. Why? Overall path, it is not traveling in the mu. Only small thickness, it is traveling in the mu. So that's why lambda we will take the, because ultimately it is coming out in the air. Then again when it will come out, lambda will become same. So it will not change the fringe width, one thing, because whole experiment I am not performing in the liquid of refractive index mu. Only small thin slab I introduce in the front of the one of the slit. So fringe width will not change, one thing. Second thing, central maxima will get shifted. Where it will get shifted? Where we are introducing the slab. Where we are introducing the slab. Why? Slab will introduce the extra path length. Okay. Okay, how much distance the central maxima got shift? Then t into mu minus 1 we will equate with dy by capital D. How many fringes central maxima got shift? Then t into mu minus 1 we will equate with n lambda. Okay, if they are saying central maxima got shift to the position of the first minima, then what is the t? Then t into mu minus 1 I will equate with lambda by 2. If it is shifted to the second minima, so t into mu minus 1 I will equate with 3 lambda by 2. Like this they can ask in this topic. Okay, everybody got? Then it is enough, I think. And rest question you will solve from the module and whatever given in the notes. Okay, and one more thing you have to remember, in the YDSC, if they are asking width, they are changing the width of the slit. So I said in the beginning also, intensity we are directly taking the width of the slit. Intensity we are taking width of the slit. In JEE Main 3-4 years back they asked the question. In that they mention, take the width is directly proportional to amplitude. Take width is directly proportional to amplitude. So if they given this type of condition, then you have to use accordingly. Then I will say what? Intensity directly proportional to width square. Intensity directly proportional to width square. Okay. But if they have not given, then according to the past PYQs, intensity is directly proportional to the width. So when they double the width, intensity we will take double. Everybody got or not? Okay. Monday my class is there or not? How I know that on Monday my class will be there or not? Okay then, bye bye.